Hello, awesome Algebra 1 students, and welcome back. Today in this video, we are going to be going over our properties of exponents again. So just as a reminder, we have our product of powers, our quotient of powers, and our power of powers. But this time, we're going to be looking at what do all of those look like when you have a coefficient. Now, if you don't remember what a coefficient is, a coefficient means a number multiplied by a variable. So for example, if I were to write down 2x, the coefficient would be 2, and this is equivalent to 2 times x. So in all of our videos with properties of exponents, we haven't had to deal with coefficients. That's going to be something new for today. So we're going to start with a quick warm up on the properties just to make sure that we feel comfortable with them. Then we're going to go into some notes and some examples of how the properties work with coefficients. And then we're going to end with an exit ticket, obviously going over more examples. So grab a paper and pencil and get ready to go. Okay, so just as a reminder for our warm up, we have 3 properties that we've learned about so far. In a product of powers, when you're multiplying 2 powers with the same base, you can add the exponents because you're just continuing on the multiplication. Quotient of powers, when you have a quotient of 2 powers with the same base, you can subtract the exponents because you're just going in and creating big ones. And in a power of powers, when you have a power raised to an additional power, you can multiply the exponents because you're just essentially multiplying that base by itself whatever amount of times. So we're going to do a couple of different examples. In fact, what we're going to do is we're just going to do 4 different examples, and I'm going to weave in some negative exponents as well, just so that we get that extra practice. So warm up number 1. Warm up problem number 1 is going to be x to the 4th times y to the 5th times x to the 7th times y to the negative 2nd. Go ahead and take a moment and write that one down. And again, if you would like to pause the video and try to do this one on your own, then I would say go for it and do so now. For those of you who are sticking with us, we're going to look at how to apply the properties to this problem. So for this problem, the first thing that I notice is that we have 4 different powers. We have x to the 4th, y to the 5th, x to the 7th, y to the negative 2nd. In product of powers, which by the way, this is a product of 4 different powers, you can only add the exponents if they have the same base. So for example, like I can't multiply 4 x's and 5 y's and say that it equals 9 y's, but I can multiply 4 x's with 7 x's and add those exponents together. So I'm looking now kind of like how we combine like terms. I can add the exponents of powers with the same base. So when I go to simplify, the first thing I can do here is I can identify that I have an x to the 4th and x to the 7th. So I can add those 2 exponents. I have 4 x's here, 7 more x's there. I can also do the same thing with the y's. I have 5 y's here and looks like negative 2 y's there. Remember, don't do anything with the negative, just treat it the same way you would treat if it was a positive. So I have y to the 5 plus negative 2. So I'm just applying the product of powers to essentially the same base. And now let's go ahead and simplify. 4 x's and 7 more x's is a total of 11 x's. That would be x to the 11th. And 5 y's plus a negative 2 y's is a grand total of 3 y's. And that's your answer. You can't do anything from here because remember, x and y are different numbers. So if we knew what these numbers were, like if x was 7 and y was 3, we could keep going. But we don't know what those numbers are, so we're basically stuck. And that's our final answer using product of powers. Okay, get set up for number 2. Okay, for number 2, we're going to look at one like this. Let's go x to the 5th times y to the negative 3rd divided by x to the 4th times y to the 7th. I don't know. I just made that one up. Okay, so we have a quotient of powers. I think that's pretty obvious because it is a quotient with powers, right? We're trying to make this as easy as possible on you. And again, we're dealing with powers with base x and powers with base y. So remember, you can only apply the properties on powers that have the same base. So I can only subtract the exponents from the y's and subtract the exponents from the x's and vice versa. So let's just take these one step at a time. First thing I'm going to look for is I'm going to look at these these x's. And I go, okay, where are there more x's? Are there more x's in the numerator or are there more x's in the denominator? Well, we have 5 in the numerator and we have 4 in the denominator. So which one has more? The numerator has more, which leads me to believe that when I cancel out all those big ones, where are x's going to be left? We're going to be left with more x's in the numerator. Just remember, you can always write this out as a reference. X to the 5th means I have x times itself 5 times, and x to the 4th means I have x times itself 4 times. And remember, these all become big ones. Well, the one that has a larger exponent is going to be left with that in the numerator or the denominator, wherever it is. So just remember that. You can always write it out. Okay, but if we're using the quotient of powers property, we're subtracting these exponents. But I notice there are more in the numerator, so I'm putting this work in the numerator. X to the 5 minus 4, because I'm taking 4 of these 5 out and I've turned them into big ones. Now let's look at the same thing with the y's. Now this is where some of you were making some mistakes. Where are there more, like a greater number? Well, last time I checked, 7 is a greater number than -3. So which one has more or which one's greater? 7, which means my y's are going to end in the denominator. Why? Because there's a greater number in the denominator. So when I cancel out those -3 y's, I'm going to be left with more in the denominator. So in the denominator, I have y to the 7 minus -3. Remember, this is a -3. And then again, just do the property as if the negative wasn't even there. All right, let's go ahead and simplify. So I had 5 x's. I took away 4 x's. That leaves me with just a single x, x to the 1st power or just x. And then I had 7 y's, and I took away the -3 y's, which actually added y's in, because if you think about it, I'm doing the reciprocal of just these, which means I'm basically multiplying more factors of y. So now I have y to the 10th in the denominator, and that's your final answer. All right, we're actually just going to do one more warm-up problem using power of powers, so get your pencil and papers ready. Okay, last one, number 3. So for this one, we're actually going to introduce something that's a little bit different that we're going to talk about in our next video, which is called power of a product, but we're going to do this the long way instead. So bear with me here. In this one, what we're going to do is we're going to look at this. We're going to go x to the 4th times y to the -3rd, and then we're going to bring the entire thing to the 6th power. Okay, so this is still a power of a power property, but here's the problem. Inside of this power, we have 2 individual bases. We have x to the 4th and we have y to the -3rd. So you have to remember that when you're dealing with individual bases, I can't add these exponents. These are x and y are not the same number. I can't add the exponents. So here's what we can do instead. We're basically going to be multiplying x to the 4th 6 times and y to the -3rd 6 times. If you think about it, I could write this whole thing out 6 times, or I could write it like this. Basically, I'm just going to say, you know what? I know I'm going to be multiplying x to the 4th 6 times. So I'm just going to give x to the 4th its own little exponent. And I can do the same exact thing with y. I know that I'm going to be multiplying y to the -3rd 6 times. So I can just go, okay, y to the -3rd 6 times. In a weird way, it's almost like distributive property. I'm basically saying, all right, I'm going to just do power of a power with the x and power of a power with the y. Now I can use the power of a power property, which is multiplying the exponents. Why? Because I'm multiplying x to the 4th by itself 6 times. So that's basically 6 groups of 4. So that means here we have, let's move this up here, x to the 4 6 times, that's 4 groups of 6, that's x to the 24th, right? 4 times 6 is 24, times y to the -3rd to the 6th, -3 times 6 is -18. Now, would that be considered an acceptable answer? Unfortunately not. We've applied all the properties, but it still has a negative exponent. So if you remember, how do you change a negative exponent into a positive exponent? you take the reciprocal of the base. But here's the thing, x has a positive exponent, and this was on one of your practice problems from before. So you're only taking the reciprocal of y. That's the tough part, okay? So you're gonna leave x in the numerator. X is happy in the numerator with this little positive exponent and everything's good. Y, unhappy. It has its negative exponent, not good. So our final answer is we've got 24 x's in the numerator and we've got 18 y's in the denominator. Because again, you can't have those negative exponents left behind. All right, now that we've done our little quick warm up, we're gonna go ahead and get into our notes. For this again, you're just gonna need a piece of paper. All we're gonna do is we're gonna go through a couple more examples, but this time, what do you do when you have coefficients? Okay, before we get into our properties, we're actually gonna deal with some common misconceptions. So these are mistakes that you don't want to make while we're going through this. So it's really important to understand what a coefficient is. A coefficient is just a number multiplied by a variable. It's part of a product, not necessarily part of a power. Let me show you what I mean. So when you have, for example, 2x, we talked about this. 2x is a product. That means 2 times x. And products are made up of what? I think I hear it coming through. Products are made up of factors. So both of these are considered factors in this product 2x. Now, here's another example, 2x squared. Now, this is where we start to make mistakes. Some of you think that this 2x squared is a power because you see the little x, you see the little square right there. So you think, oh, this means 2x times 2x. No, no, no. This is still a product. This means 2 times x squared, which could also be written as 2 times x if we wanted to do that for whatever reason. Ooh, almost knocked over my whiteboard there. And again, these are all factors. They're parts of a product. So again, same thing. What if I had 4x cubed y to the 5th? This is still a product. This is 4 times x cubed times y to the 5th. These are all individual factors, which again, if I wanted to write it out, I could write it out as 4 times x times x times x times 5y. I don't know why you would ever want to do that, but you could. So what's important to understand is that coefficients are factors. They're parts of the product, but not necessarily parts of the power. So when we start to go into applying these properties, it's really, really important that you remember that. Okay, so once you have this written down, go ahead and get some space ready for our first example. Okay, so to start off, we're going to look at examples that are just products of power. So we're looking right in here. So we're going to go over 3 examples, 1, 2, and 3, that are all product of powers properties. They may not look like it at first, but they are actually product of powers properties. So let's start off with number 1 here. So number 1, our example is going to be, here I'll use the same color just to keep it all the same, 2x to the 4th times x to the 5th. Our second example is going to be 3y to the 4th times 4y to the 5th. And our last example is going to be 2x squared y times 3xy squared. Okay? All of these are actually products of powers, okay? Or at least they're products of powers properties. So the first thing that you're going to do when you have to deal with coefficients is remember, coefficients are still parts of these products. They're actually still factors in the product. So the first thing I like to do, the first step is I like to separate all of the individual factors so that I can actually see each individual one. So my first step is always separate factors. So that could be really simple. Like here, that could just be 2 times x to the 4th times x to the 5th. So really, I'm just separating the coefficient from its next factor. Over here, that would be 3 times y to the 4th times 4 times y to the 5th. And again, all I'm doing is I'm separating the coefficient from its power. Over here, that would be 2 times x squared times y times 3 times x times y squared. That would be my first step, my recommendation. And you don't have to do this. You could actually skip over this step later on if you wanted to. So now that I've separated, I'm looking for common bases or common types of factors. Now that gets a little bit confusing, but I'll show you what I mean. Over here, the thing that jumps out to me is I have 3 factors in my product. I have 2, I have x to the 4th, and I have x to the 5th. Only 2 of those can actually be simplified, and they're the 2 that have the same base. I can apply product of powers property to x to the 4th times x to the 5th. Basically, this is 2 times 4 x's times 5 more x's. So what is that going to be in the end? That's going to be 2 times a grand total of how many x's? Well, what's 4 plus 5? That would be 9. So showing the math, this is 2 times, if I'm applying that product of powers property, I'm adding those 4 x's with those 5 x's. And my final answer is 2x to the 9th. So the coefficient in example 1 just kind of came along for the ride because there wasn't anything that I could multiply it with. There weren't any common factors or common factor types, I should say. Now let's look at number 2. This one's a little bit different. Now I see 4 y's here and 5 y's there. So automatically I know that that's a grand total of 9 y's. But the other thing that stands out to me in this one is I see 3 times 4. And last time I checked, I know how to multiply 3 times 4. Those are what we call a common factor type. Like terms, you can always multiply coefficients. So really what I'm going to do here is I'm going to do 3 times 4, because that's math that I can do, times 4 y's plus 5 more y's. So I'm only applying the product of powers property to the powers, but at the same time, I'm going to multiply those 2 coefficients because I can. And simplify means do as much math as you can. So 3 times 4 is 12, 4 of those y's, and then 5 more makes y to the 9th. So my final answer here, 12y to the 9th. If you want to try to do number 3 on your own, go ahead and pause the video now. For those of you sticking with me, let's go ahead and get this one done. I think we're going to be able to do this one pretty quickly now. Okay, so first thing that stands out to me is I see a 2 times a 3. That's a common factor type, right? I can do 2 times 3 last time I checked, right? Okay, so I know I'm going to multiply 2 times 3. I also see an x squared with an x, and I know this has a hidden coefficient of 1. So that means I've got 2 x's here and 1 x there. I can combine those into a single power. And then the last thing I see is I have a y here, which I know could be written to the first power, and 2 y's there. So I know I can apply product of powers, and I can multiply 2 times 3 because that's simple math. 2 times 3, we all know that. So here's what it looks like. We've got 2 times 3 happening. We've got x to the 2 plus 1 because we're going to add those exponents. And we've got y to the 1 plus 2. So let's do the math. 2 times 3 is 6. 2 x's here plus the 1 more there is x to the 3rd. And 1 y there plus the 2 more there is y to the 3rd. Oops, I did that in the wrong color. Oops, I'll change it. But you get the idea. I'm doing as much math as I can, and then my answer is a simplified product. So your answer should always have a coefficient when you're dealing with product of powers. It should have a coefficient, and then most of the time it'll have some type of power involved in it. There we go. Now it's all about the thing. Okay, so that's how product of powers works with coefficients. You're just going to treat it like another factor, like more math that you can do. I can multiply 3 times 4 and I can multiply 2 times 3. So if you can do the math, you might as well do it. All right, now we're going to look at what quotient of powers looks like with coefficients. That's where it gets a little bit tricky. So go ahead and get your paper ready. for examples 4, 5, and 6. Okay, quotient of powers with coefficients, examples 4, 5, and 6. So get your paper ready and follow along. So we're going to treat coefficients just like normal factors in a product, but quotients are different. When you see quotients with coefficients, you got to think about fractions a little bit. Don't get freaked out. It'll be okay. So we'll start off with a basic example without having to simplify, and then we'll get a little bit more complex. So first example, let's just do 3x to the 4th divided by x to the 6th. Over here, we're going to do 4x to the 5th divided by 2x to the 3rd. And then over here, we're going to have a little more fun. How about 4x to the 3rd, y to the negative 2nd, because why not? Haha, why not? Divided by 6x to the negative 4th, y to the 5th. I don't know. That seems like a fun one, doesn't it? I think that looks fun. Okay, here we go. So quotient of powers. If you have the same base, you can subtract the exponents. So kind of the same first thing that I would do, I would separate your factors. So whenever you have coefficients, whenever you start to see integers thrown in there, step one, separate your factors. So what does that look like? That just means I'm going to put space between my coefficients and my factors. So over here for number 4, this is just 3 times x to the 4th divided by x to the 6th. Over here for number 5, that's, I'm going to put it over here, 4 times x to the 5th over 2 times x to the 3rd. And then over here, I've got 4 times x to the 3rd times y to the negative 2nd divided by 6 times x to the negative 4th times y to the 5th. So all I'm doing is I'm just putting space, I'm separating my factors so that I now realize that 4 is its own factor. It's not being affected by this power. That's just 4 times 3 x's times negative 2y. This is 3 times 4 x's. Got it? All right, just like the last examples, the next step is apply the property. So the property states if I have 2 powers with the same base, I can subtract the exponents. And then the coefficient just kind of comes along for the ride. So over here, let's take a look. I've got 3 in the numerator. It's going to stay there because there's no coefficient to simplify it with in the denominator. So I know my final answer is going to have 3 in the numerator. That's not going anywhere. Now here we go. We've got 4 x's in the numerator and 6 x's in the denominator. Which one has more? 6 is more than 4. So that means our x's are going to be in the denominator. These 4 x's will be canceled out with 4 of these 6 x's. They're all going to be big ones. So in the denominator, I've got x to the 6 minus 4, which means my final answer for number 1 is 3 divided by x squared. Again, that 3 is its own factor. It stayed in the numerator. It's not affected by the quotient of powers property. All right, let's take a look here at number 5. So this is an interesting one. I have 4 in the numerator and I have 2 in the denominator. But if you think about it, that's basically saying what's 4 divided by 2? Or in other words, if I had 4 over 2 or 4 halves as a fraction, what would that be simplified? Last time I checked, you can simplify 4 and 2, right, by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. So I'm essentially simplifying the fraction. That's where it gets tricky with coefficients in quotients. So now I'm left with 2 in the numerator, 1 in the denominator. That's just with the coefficients. Now let's look at the quotient of powers. I have 5 x's in the numerator and 3 in the denominator. Which one has more? Last time I checked, 5 is more than 3, which means 3 of these 5 are going to be eliminated, and all 3 of those are eliminated. In other words, my x's are going to stay in the numerator. So final answer looks like, again, that's just a placeholder 1 that I don't need anymore. Take away those 3 x's from those 5 x's, and you're left with 2x squared. In the numerator with nothing left in the denominator. The 2 was eliminated with the 4, and the 3 x's were eliminated with the 5 x's. All right, how about this last one? This looks like fun, doesn't it? By the way, if you want to pause the video, go ahead and do it now. For those of you that are sticking with me, here we go. Let's deal with the coefficients first. I see a 4 divided by 6. Now I know 4 divided by 6 is not a whole number, so I can't divide. But 4 sixths, I'm pretty sure 4 and 6 have a common factor. And I'm pretty sure that factor is 2. So let's go ahead and simplify this fraction by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So now that leaves me with a 2 in the numerator and a 3 in the denominator, right? If you can do math, you do it. That's how math works, and that's how simplifying works. If I can do some math, by golly, I'm going to do math. And yes, I just said by golly. Okay, now let's take a look at the x's. So we're going to apply our quotient of powers. I have 3 x's in the numerator, negative 4 in the denominator. 3 is more than negative 4. So in the numerator, I'm going to be doing x to the 3 minus negative 4. Look at the y's. I've got 5 y's in the denominator, negative 2 in the numerator. 5 is more, which means our y's stay in the denominator. 5 to the y to the 5 minus negative 2. And let's simplify. So if I have x to the 3 minus negative 4, that means x to the 7th. So in the numerator, I have 2x to the 7th. Denominator, I've got 3. And then y to the 5 minus negative 2 is y to the 7th. Now, some of you might be like, wait, I've got 7 and 7. Is that a big 1? It's actually not, because this is 7 x's, this is 7 y's. Last time I checked, x and y are not the same number. We are done. So that's how quotient of powers works with coefficients. Okay, last one we're going to look at is power of powers, and we're actually only going to do 2 examples for power of powers. So we'll do 7 and 8, and then we'll wrap up with a quick exit ticket. 2 examples that are really crazy and out there and wild and like scary, and then that'll be it for today's video. Okay, 7 and 8, we're going to be looking at power of powers with coefficients. So these examples will be relatively quick because we kind of already talked about it in the warm-up. So for number 7, we're going to have 4y to the 3rd power raised to the 2nd power. And for number 8, we're going to have 10x to the 2nd power, y to the negative 3rd power to the, I don't know, 4th power. How about that? That looks fun, doesn't it? Okay, here we go. Now, same thing. First step that I always do is I separate the factors. The coefficients are their own factors. Separate them from the powers. Just give them some distance, okay? So inside the parentheses, the first thing I'm going to do here is I'm going to separate the 4 times the y cubed. It sounds silly. Like, why does she always have us do that? Trust me, if you don't do that, if you don't think of them as separate, all you're going to do here is you're going to just multiply 3 times 2, call it 4y to the 6, and be done. And you would be wrong, okay? Separate the factors. Here, same thing. I'm going to separate inside the parentheses 10 times x squared times y to the negative 3rd raised to the 4th power, okay? Separate them. Put some distance in there. Got it? Okay, second step. Now, this is where, ooh, the whole thing almost fell over. This is where things get a little bit tricky because of the power of a power. This means I'm going to multiply 4 by itself 2 times and y cubed by itself 2 times. So if you remember from the warm-up, what we're going to do next is we're going to write both of these as individual powers. So that means I'm thinking ahead. I'm thinking, like, if I were to write this all out, I'm going to end up having to multiply 4 by itself 2 times and y cubed by itself 2 times. So basically, I'm going, okay, so then I'm just going to write it out like this. 4 squared times y cubed squared. Like, I'm just thinking ahead. 4 times 4 and y cubed times y cubed. Now I can apply the individual properties. So at this point, if I can simplify 4 squared, I'm going to do it. Can you simplify 4 squared? Yes, 4 squared is 16. Because it's a coefficient, it's not a power, we're actually going to do that math. So 4 squared is 16, and I have 2 groups of 3 y's, which means I have a grand total of 6 y's. And my final answer here is 16y to the 6th. you see how if you didn't separate these two, you would have forgotten to multiply 4 by itself. So separate your factors first. Okay, over here, we're gonna do the same thing. We're gonna separate our factors, and we are keeping in mind, we're gonna multiply 10 by itself 4 times, x squared by itself 4 times, y to the negative third by itself 4 times. So here we go. We have 10 to the 4th times x squared to the 4th times y to the negative 3 to the 4th. And notice, I don't even deal with the negative right now. Like that future Miss Angel can figure that out. Okay, let's do some math. Now here's the cool thing with tens. The rule with tens is that whatever the exponent is, that's how many zeros it's going to have. Like 10 times 10 is 100, 100 has 2 zeros. 10 times 10 times 10 is 1,000, 1,000 has 3 zeros. So 10 times 10 times 10 times 10 is going to be 10,000 because that has 4 zeros. I don't know if you knew that or not, but now you do. So now we have 10,000, 1, 2, 3, 4. X squared 4 times, that's a total of 8 x's. And y to the negative third 4 times is a total of negative 12 y. Is that acceptable? No. Y is unhappy. Why is y unhappy? Because y has negative exponents, and negative exponents are no-nos. So remember, if I were to keep these little spaces between, the only one that's not happy is y. Because 10,000 is its own number, x has a positive exponent, negative 12 is the only unhappy one. So let's make it happy. Let's use the reciprocal of the base. 10,000 x to the 8th stays in the numerator. Y to the 12th moves down to the denominator where it's happy now because it has a positive exponent. And there you go. We are done. If you notice, there is a common theme among everything. Every time you have a coefficient, the first thing you do is you separate the factors. So just keep that in mind when we go over our exit ticket, which is numbers 9 and 10, and that will wrap up this video. All right, here we go. Now, just a warning, these ones are definitely going to be more complex. They're going to have a lot more steps for you to do, but we're going to treat the steps the exact same way as before. So here we go, number 9. Let's do 10x to the 4th, y to the negative 2 over 12x to the 5th, y to the negative 3rd, x to the 3rd. Ooh, I like that one. I like that one a lot. Sorry, that's a little mean. Okay, over here for number 10, we're going to do in the numerator, how about 3x squared to the 3rd power divided by 4x cubed to the 2nd power times x to the negative 5th power. I like that one too. Now, again, you might be looking at these like, what on earth is she talking about? Remember, the first step is always the same. Go in and separate your factors. Just rewrite the expression, but this time with separation in. Like, it just makes things way clearer when you do it that way. So here we go, number 9. Let's go in and let's just separate our factors. So we're basically rewriting the expression again, but this time with little spaces. And trust me, it makes a difference. So in the numerator, we're going to do 10 times x to the 4th times y to the negative 2nd. In the denominator, 12 times x to the 5th times y to the negative 3rd times x to the 3rd. Just separate them, right? Like put some space in there. All right, then let's just go do some math. Like whatever you see that can be done, go in there and do it. So the first thing that stands out to me is we've got a 10 and we've got a 12. And if I look at 10 12 as a fraction, I know that 10 12 can be simplified. 10 and 12 are both divisible by 2. So I'm just going to go in there and simplify that fraction. 10 divided by 2 is 5. And 12 divided by 2 is 6. So at least I know that my next step is going to have 5 in the numerator and 6 in the denominator. And maybe I don't know anything else at this point, but at least I've got something, right? I've done some math. Okay, now I notice I have some bases down here where I have an x to the fourth and x to the fifth, but I also notice I've got a product of powers down here. Look at that. I've got 5x's here and 3x's there. So I think the next thing I'm going to do is I'm going to combine those. That would basically be x to the 5 plus 3, which in other words is x to the 8. So all I've done is I've done our product of powers. I've wrote those as a single power. And then I still have those 4x's in the numerator. I just haven't dealt with those yet. Like, don't worry about it. Ooh, and then I've got y to the -2 and y to the -3. Ugh. Well, let's think about it. Which one is technically greater? I know it seems like 3 is larger, and it is, but -2 is greater than -3, which means you'll always end up with more in the area where the exponent's greater. So because it's greater in the numerator, I know my answer is going to end up in the numerator. Okay, I know that kind of was worded weirdly, but wherever the greater exponent is, that's where your factors are going to end up. So -2 is greater than -3. That means in the numerator, I'm doing -2 minus -3. Quotient of powers, greater minus lesser. All right, there's some more math that I can do now. Let's see, let's start with how about 5 and 6 are pretty much done though, right? I can't do anything else with those. So I'm just gonna bring those along. I've still got 5 and I've still got 6. X to the fourth and x to the eighth. I'm pretty sure I can do quotient of powers with that. Are there more in the numerator or are there more in the denominator? 8 is greater than 4. So I know in the denominator here, I'm going to be doing x to the 8 minus 4. So I'm just going to do that math because I'm running out of room. So if I take 4 of these away from 8, I'm left with x to the fourth in the denominator. And then -2 minus -3, this is equivalent to adding. -2 plus 3 is 1. So I'm just left with 1y in the numerator. And look at that. I've done all the math that I can. I can't simplify anything else. 5 and 6 can't be simplified. Y doesn't have any, there's no other y's, there's no other x's. That wasn't so bad, was it? We got that done in like 3 or 4 steps. That's pretty good. Just by looking at it and going, I don't know, what can I do here? All right, so let's take number 10. Number 10, step 1, separate the factors. Just put some space in there. Trust me, it'll make it better. So for this one, I'm actually going to separate the factors up here to give myself more space down here to do the rest of the work. So that looks like this. In the numerator, I have 3 times x squared to the third power. Can we see that? Probably not. That's actually not a very good angle. There we go. We'll do it at that angle and hopefully I won't knock it over. And then in the denominator, I have 4 times x cubed to the second power times x to the -5th. There we go. Okay. So now I can see that I'm going to multiply 3 by itself 3 times and x squared by itself 3 times. Here I can see I'm going to multiply 4 by itself 2 times and x cubed by itself 2 times. And then I've got my x to the -5th. So let's go ahead and start doing the math. That's all that we can do, right? Just do the math. So I'm going to write this out in a couple steps. You might not have to write it out in all these steps, but I'm going to do it anyway. Okay, so in the numerator, I now have 3 to the power of 3 times x squared to the power of 3, right? Because I know I'm going to multiply 3 times and x squared 3 times. In the denominator, I have 4 to the power of 2 times x cubed to the power of 2 times x to the -5th. Again, 4 gets multiplied twice, x cubed gets multiplied twice. That x to the -5th is kind of coming along for the ride. All right, let's just keep doing math. Here we go. 3 cubed. 3 times 3 is 9. 9 times 3 is 27. So it's 27 now. Because it's a coefficient, we actually want to do that math. If it's just a power, we could leave it as 3 cubed. And then x squared to the third power, that's 3 groups of 2, is x to the 6th. So now our numerator became 27x to the 6th. 4 times 4 is 16. X cubed to the second power, that's 2 groups of 3 x's, that's also x to the 6th. And then we have times x to the -5th. Okay, this is where it gets interesting. I'm going to pop in and pop out. There's a couple different things that we could do from here. The first thing that I noticed, well, actually, the first thing I noticed is 27 and 16. I'm pretty sure they don't have any common factors because 27 is 3 times 9, 16 is 4 times 4, 2 times 8. Yeah, I'm pretty sure 27 and 16 are fully simplified. Nothing we can do about those. But here's the interesting part. We could go two different directions here. I see an x to the 6 over an x to the 6, which some of you might be yelling out like, ah, that's a big 1. And you would be totally correct. So one way you could do this is I could just be like, oh, that's a big 1. Look at me go, right? And then you would have 27 in the numerator and 16x to the negative 5th in the denominator. Now, here's the only problem with doing that method. You are left with a negative exponent. So just remember that 16 is not part of it. X to the negative 5th, it has the negative exponent. So we're going to do the reciprocal, meaning it moves from the denominator into the numerator. And we have 27 x to the 5th over 16. So that's one way to do this, is that you just notice you had 6 x's and 6 x's, you made a big 1. That negative 5 x's in the denominator gets moved to the numerator. Everybody's happy. Yippee-ki-yay, right? The other way you could have done this, so I'll do a slightly different shade of green, right? So we were down here. We had 27x to the 6th in the numerator. The other way you could have done this is that this is just a product of powers. So I could have just done 6 plus negative 5. So really that would have been 16x to the first power, because 6 plus negative 5 is 1. I'm taking 5 of these away, I'm left with 1. And then I do quotient of powers again. Well, what's 6 minus 1? That would just look like this, 27x to the 6 minus 1 over 16. And guess what? 6 minus 1 is still 5. I know, totally crazy, right? Insane. That's what I love so much about these types of problems. Okay, so that is your lesson for today. Those are the properties of exponents with some coefficients thrown in there. And just remember, separate your products and then just go in there and do as much math as you can until you can't do it anymore. All right, have fun simplifying your powers, and I'll see you next time.